In this video I would like to discuss vectors. Vectors for GCSE Maths is one of those topics that people tend to find hardest. Some questions are very challenging, but understanding the basics isn't very difficult. So what are vectors? Vectors describe a movement from one point to another. We need to be able to identify two characteristics of vectors, magnitude and direction. So magnitude is how large something is. Magnitude comes under the umbrella term scalar. A scalar quantity is just a number. It only has a magnitude, such as size, for example length of a line. And the magnitude of a vector can be found by the length of the line segment. So the direction of a vector is the orientation of the vector. So that is the angle it makes with the x-axis. A vector quantity has both magnitude and direction. It is usually represented on a diagram by a straight line with an arrowhead to indicate direction. The diagram shows a journey from B to A and can be described by the vector BA. Let's discuss vector notation. So vector notation is how we write vectors in mathematics, and we write vectors in several ways using an arrow, bold-faced when typing, and underlined when handwriting. So for example, BA, we show an arrow above to indicate the direction of the journey, and also a bold-faced C or an underlined C. We call vector BA C in bold in this example. A vector representing the move from point A to B, which will be in the opposite direction, or is called an opposite vector, but has the same length. We would represent it as AB equals minus C in bold and also minus C underlined. The key thing to look at is the direction of the arrow of the vector to understand which direction the journey is going. If it's moving in the opposite direction of the arrow, then we always write a negative number. Don't worry if you find this difficult to understand, we will go through some examples to help. Let's discuss equal vectors. A vector is said to be an equal vector to another vector if they both have the same magnitude and the same direction. In simple words, we can say that two or more vectors are said to be equal vectors if their length is the same and they all point in the same direction. We can also say that two or more vectors are equal if they are co-directed. What I mean by that is directed in the same direction, collinear, lie on the same line, and have the same magnitude, i.e. the same length. This implies that equal vectors are also parallel vectors. Generally, we can check for equal vectors by comparing their coordinates. Let's look at parallel vectors. If all the coordinates of two or more vectors are the same, they are said to be equal vectors or parallel vectors. So AB is equal to CD, which is equal to EF, and they are all equal to little a. The three vectors are equal vectors, but are not co-initial vectors. I mean by that they don't start at the same point. Parallel vectors do not need to have the same initial points. They are parallel and co-directed vectors with equal magnitude. Let's take a look at opposite vectors. Here we have the vector AB. We know this from the arrow as we go from A to B, and AB is equal to A. If, however, we wanted to go in the opposite way from B to A, then BA will equal minus A. This means that we are going in the opposite direction of the vector AB. So when we are looking at opposite vectors, we're looking at the opposite direction of where the arrow is going, so the direction of the vector will be negative. Let's take a look at column vectors. Looking at our example of the journey from A to B, we have drawn this on the grid. We can see that we have a step of 2 squares to the right and 3 squares up to get from point A to B. We can write this as a term called a column vector. We use column vectors to give information about a vector. A vector has two components. There is the horizontal component, also known as the x component. This is a top number in the column vector and tells us how many spaces to the right or left to move. If the number is positive, the direction is to the right. If the number is negative, the direction is to the left. There is the vertical component, also known as the y component. This is the bottom number in the column vector and tells us how many spaces up or down to move. If the number is positive, the direction is upwards. If the number is negative, the direction is downwards. In our example, the top number, which in this case is 2, means movement to the right of the grid. The bottom number, which in this case is 3, represents movement up. The top figure is always how far to the right you are moving, and the bottom is how far up. So if you're moving to the left or down, then the values will be negative. An example of this is -2, -4, which means that we have movement of 2 to the left and a movement of 4 down. Notice that the horizontal component and the vertical component make a right angled triangle. We will go through examples further in this video to make sure you understand this and how we can use this right angle to come up with magnitudes of vectors. So let's now look at the magnitude of a vector, or put another way, the length of the arrow. As mentioned previously, vector components make right angled triangles, so we can use vector components and Pythagoras' theorem to find the magnitude of the vector. Let's go back to our example AB. The length of the vector is its absolute value, and we use the modulus symbol to represent this. So the equation looks like this: A is equal to the square root of x squared plus y squared. Now this is Pythagoras' theorem. Using this example, we have x is equal to 6 as we move 6 squares to the right from point A, and y is equal to 3 as we move 3 squares up to reach point B. Let's substitute these values into the previous equation. So we have the square root of 6 squared plus the square root of 3 squared, which gives us square root 45. Now if the magnitude is equal to 1, then the vector is known as a unit vector. If the magnitude is equal to 0, then the vector is known as a zero vector. Let's take a look at vector addition. Vector addition is adding one vector to another vector. This is sometimes known as the vector sum. When two vectors are added or subtracted, the vector produced is called a resultant. The resultant is identified by a double arrowhead. Let's take the example of these two vectors, vector A and vector B. We can write vector A and B in terms of column vectors. So vector A can be represented by 5 and 3, that is 5 spaces to the right and 3 spaces up, and B can be represented by 3 and -1, so that's 3 spaces to the right and 1 space down. Vectors can be added by placing them end to end. To do this, we add the individual components of the first vector to the second vector. So in our example, vectors A and B can be added by placing the vectors end to end. Here we are saying we go along A and then to B, so we add vector B onto the end of vector A. Vector A plus B is also called the resultant vector. The resultant vector is 8 to the right and 2 up. Now we've done this graphically, but we can also calculate this by adding the column vectors. When adding vectors, the order in which we add the vectors is not important. We will get the same result if we start with vector B and add vector A. Let's try vector subtraction. Vector subtraction is subtracting one vector from another vector. When subtracting vectors, the order is important. To do this, we subtract the horizontal components, top numbers of the column vector, and subtract the vertical components, bottom numbers of the column vector. So in this example, we have A minus B, which is 5 and 3 minus 3 and 1. So we can say we have 5 minus 3, which gives the horizontal component, and 3 minus 1 to give the vertical component. What minus B means is the opposite direction of B. So the final answer here would be a vector of 2 and 2. Let's look at subtracting vectors graphically. Subtracting vectors is based on the addition of vectors. The first vector stays the same, but the second vector reverses the opposite direction to become a negative vector. So we have A minus B, which is the same as A plus minus B. Let's look at our example of A is equal to 5 and 3 and B is equal to 3 and 1. Graphically, they can be represented like this. Since we are calculating a minus b, we need the vector minus b. The direction of vector minus b is opposite to the direction of the original vector b, but has the same magnitude. So b is 3 and 1, and minus b will be 3 and minus 1. We know from vector addition that when adding two vectors, we add the second onto the end of the first, such as this. The final answer is the blue arrow as the resultant vector. And the answer is 2 horizontal and 2 vertical, the same as when calculated using column vectors. Let's try another example. Vector A has a column vector of 6 and 4, and B has a column vector of 3 and 2. A minus B is equal to 6 and 4 minus 3 and 2. So to calculate vector A minus B, we subtract the x components, the top numbers, so 6 minus 3, which gives us 3, and then the y components, the bottom numbers, 4 minus 2, which gives us 2, giving a resultant vector answer of 3 and 2. Let's look at vector multiplication. Vector multiplication is when a vector is multiplied by a number. The number is a scalar and has magnitude only, whereas a vector has magnitude and direction. To multiply a vector, we multiply each of the components by the scalar number. So let's go through an example. Vector A is 3 and 1. So multiplying vector A by 3 would be 3a is equal to 3 times vector 3 and 1. And that is the same as 3 times 3 and 3 times 1, which gives 9 and 3. Now graphically we can go from vector A to vector 3a like this. So we tripled the length. We can think of multiplication as repeated addition. So we can also say multiplying the vector a by 3 would be 3a is equal to a plus a plus a, which is equal to these vectors combined, so 3 plus 3 plus 3 and 1 plus 1 plus 1 gives us an answer of 9 and 3. Now as you can see, we can visually say these are 3 lots of x component and 3 lots of y component. The direction of the vector when it's multiplied by a scalar number is the same as the original vector, but the magnitude of the vector, also called the absolute value of the vector, has changed. Let's go on to an example question. So in the diagram, N is the midpoint of BC. Question is, find vectors AN, PC and AC in terms of A, B and N. Now, before we begin, to obtain an unknown vector, we need to try and get there using any root made up of known vectors. So to get to AN, we need to go from A to P to B and then N. To get to A to P, we need to go in the opposite direction of the arrow. So this makes it minus A. Then we add B and N as this follows the direction of the vector. To get to P to C, we need to go from P to B and then N to C. Since N is halfway between B and C, we can say BC is equal to 2N. This gives PC is equal to B plus 2N. To get to AC, we need to go from A, P, B, N and then C. Since N is halfway between B and C, we can say BC is equal to 2N. And to get from A to P, we need to go in the opposite direction of the arrow. So this makes it minus A. So AC is equal to minus A plus B plus 2N. So now let's look at vectors along a straight line. We can use vectors to show that points lie on a straight line. To do this, we need to show that the vectors along each part of the line point in the same direction. We are trying to show that they are scalar multiples of each other. So in this example, if ABC is a straight line, then AB must be a scalar multiple of BC, as they are in the same direction. So put simply, if you multiply AB by a number or a scalar, you can create the length BC. Let's go through an example question. In the diagram, PD is equal to y, AD is equal to 2z, DC is equal to y minus z, and CB is half y minus 4z. The question here is, show PAB is a straight line. Firstly, we need to work out the vectors along the two parts of PAB, PA, and AB by using the vectors we know. So PA is equal to PD plus DA. DA is equal to minus AD, which is minus 2z. We say minus 2z as we are moving in the direction DA, which is the opposite direction of the arrow AD. So PA is equal to y plus minus 2z, which is the same as y minus 2z. To work out AB, we need to go from AD to DC to CB, which gives us 2z plus y minus z plus half y minus 2z. We can simplify this by adding the same letters together, which gives us 3 over 2y minus 3z. Finally, which gives us 3 over 2 bracket y minus 2z bracket close. Now, the next step is to check that AB is a scalar multiple of PA. Since we know that PA is equal to y minus 2z, we can substitute this into the vector we calculated for AB, which gives us AB is equal to 3 over 2 PA. So PAB is a straight line, as we have proven that AB is a scalar multiple of PA by the fact that we have shown the relationship of AB being equal to 3 over 2 PA. Let's look at vectors and ratios. There are questions involving ratios and vectors. Ratios are used to tell us about the lengths of different sections of a straight line. For example, if you know the vector along part of that line, we can use this information to find other vectors along the line. In this example, we have a line of OPQ, where the ratio of OP to PQ is 2 to 3. What this means is that OP is 2/5 OQ, and PQ is 3/5 OQ. Why the numbers are over 5 is because we add 2 and 3 together to give us the total, and the values are based on the ratio of the total. Let's go through a question here. JKLM is a parallelogram where JK is parallel to ML and JM is parallel to KL. Point N lies on ML such that the ratio of MN to NL is equal to 3 to 1. KL is equal to A and KJ is equal to B. Find JN in terms of A and B. So the first step is to write JN as a route along the parallelogram. So we have JN is equal to JM plus MN. We now use the parallel sides to find JM and ML. Since JM is parallel to KL, we can say that JM is equal to KL, which is equal to A. ML is parallel to JK, which is equal to minus B. It's minus B because the direction of the arrow goes from KJ, and we are going in the opposite direction from M to L. We then use the ratio to find MN. So MN is equal to 3/4 ML, which is equal to 3/4 of minus B, which gives us minus 3/4 B. We now use JM and MN to find JN. So JN is equal to JM plus MN, which is equal to A plus minus 3/4 B, which is the same as A minus 3/4 B. That's all for this video. Hope you found this useful. If you did, please give a like and subscribe, and I will see you again in the next video.